infinite geometric series. So what does this mean? Well, geometric, again, meant that we are multiplying between terms. Oops. So that means we've got a common ratio. Our series means that we're adding up. We're doing a sum of the terms. And now infinite. This is telling us that we're going to have dot, dot, dot. The geometric series that we've done so far had an ending point. We stopped at a certain place. Now we're going to add up all the way to infinity. Ooh, sounds interesting. So now we've got 0.6 repeating. We need to put that into a series. Ooh, what are they even asking about there? Well, let's kind of rewrite that. That means 0.666. And keep on going on. 6 after 6. So now we need to break that up into a series. So that means something plus something plus something plus something plus something all the way along. Well, what are we going to be able to break them up into? Well, how about we break them up into each of the different parts of the sixes? So really it's the same kind of thing you did, back in grade 3 when they said, hey, expand this number into the ones and tens and hundreds and thousands. We're just now using the decimals. Let's expand it into the tenths and hundredths and thousandths, etc. So the first spot, the tenth, 0.6. The second spot, 0.06. That's the hundredth. Now the thousandth spot, 0.0006, and on and on. So what type of series is it? What kind of sequence we got going here? Do we have an arithmetic? Do we have a geometric? Or do we have neither? Well, the way that we're going to find out, let's do a quick test. If it's arithmetic, if it was arithmetic, then that would mean common difference. Well, how did we find that d value? Oh yeah, we went t2 minus t1, and it's going to be exactly the same as t3 minus t2. So let's check that out. 0.06 minus 0.6, is that the same as 0.006 minus 0.06? No. So no go on that one. It is not arithmetic. Let's check out geometric now. If it's geometric, that would mean it needs to have a common ratio. Well, if it has a common ratio, the common ratio is found by taking the ratio of the two. T2 divided by T1, or T3 divided by T2. And they've got to be the same number. So let's check this one out. Is 0.06 divided by 0.6 the same as 0.006 divided by 0.06? And oh, hey, look at that. They are. It comes out to 0.1, or in other words, 1/10. We like to use fractions instead of decimals there. That kind of makes sense, because the places where tenth, hundredth, thousandth, 1/10 of each. All right, having some fun. And again, if you haven't done this question yet, pause, do it yourself, work it through, make the connections, and then see if you're right. All right, draw a square. Close enough. Beautiful. Divide it into 4 equal squares. Close enough. Shade one of them. Beautiful shading. Now, divide one of them into 4s again. And shade one. And do it again. And shade. And do it again. And shade. and do it again, and shade, and do it again, and shade. Okay, so you get the idea of what's going on there. Now notice what's happening. If I wanted to know what's the area of the shaded area that I've created. Well, every single time I'm adding less and less and less. Eventually, I'm going to be adding such a tiny, minuscule amount. It's going to get to a value and not really go higher than that value. So let's make a little chart here so we can figure out what's going on. Let's do square number. So then we got 1, 2, 3, 4, 5 of them. And then what's the area of that square? And then let's find out what's the area of all of it, the sum of them. Well, that first square, this one right here that we're talking about, that one was 1/4. That was 1/4 of the whole amount there. The second one, that's this one here that we're talking about. That one, well, that's 1/4 of 1/4. That's 1/16 of the whole. And then the next one, the third one, that would have been 1/4 of 1/4 of 1/4, 1/64. And then the next one, 1/256. Next one, 1/1024. Well, the first one's going to be 0.25. Now the next one's going to be 0.25 plus the 1/16. So we're going to have a bit more than 1/4. That's 0.3125. And now take this 0.125 and add 1/64 to it. 0.328125. Notice, yeah, we went up, but we didn't go up as much as we did. Add the next one. 0.332031. Ooh, run out of room. 25. And the last one there, adding that on there, give myself a little bit more room. And when we add that 1 of 1024, we get 0.3330078125. And we could keep this process going. We'd add a little bit more, a little bit more, a little bit more. But you know what? We're not adding much. And we can kind of guess, what number do we think that we're getting close to? Well, that number there is getting pretty close to 0.333 repeating. Or in other words, 1/3. So an infinite geometric series has an infinite number of terms. For an infinite geometric series, if the sequence of partial sums converges, ooh, that's a key there. Let's highlight that. To a constant value as the number of terms increases, then the geometric series is convergent, and the constant value is a finite sum of the series. Or in other words, we can go the sum to infinity, denoted like this. Love this symbol. A little fallen over 8. It's only going to work when it's converging. We've got to be coming towards a number, so we're adding less and less and less. All right, predict whether each infinite geometric series has a finite sum. In other words, can you find the sum to infinity? Well, 1/3, 1/12, 1/48, we're adding less and less and less. If we're adding less and less, then yeah, we're going to be able to. All right, well, we're going to add these up. You could just punch it straight into your calculator, which would be the easiest way to do it. But this is 0.3 repeating, plus this one's 0.4, oops, after, no. 0.3 repeating, then 0.416 repeating after we add the 112, then after we add the 48th, we're going to get 0.4375. Then when we add the next one, the 1 over 192, we get 0.4427. And if we go into the next one, we'd be adding 1 over 768, which is then going to take us to a sum of those first 5 to be 0.4440. Well, you know what? It kind of starts looking like it's about 0.4 repeating. We're going to get 4s, 4s, 4s. You can keep going and see what happens. Yep, it gets closer and closer. 0.4 repeating, hey, that's 4/9. Well, how about the next one? -4, -8, -16, -32. If we keep adding those, we're going to get a number, going to get bigger and bigger and bigger, 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 bigger. We can't do this. This is divergent. If it's divergent, we can't do it. Can't find that sum. So we say, does not have a finite sum. The number is just going to keep getting further and further away from 0 into the negatives there. Ooh, look at this tricky one. It goes positive, negatives, positive, negative. So then, does this one have a finite sum? Or because it's positive, negative, does it not? Well, it comes down to, is it convergent? Does it come closer and closer to a value? And this one, yes, it does. It's getting smaller and smaller and smaller. It's getting closer to 0 for each what we're adding. We're adding very little bit at the end. So yeah, we're going to be able to do this one. Well, let's check it out and see what happens. After the first one, we get 0.1. Then when we add the second one, we get S1 plus a -1/100th, or 0.09. Oh, look, we're getting less. Then when we go to the next one, 0.091. And then when we go to the next one, we're going to be adding a negative, so we're going to come down 0.0909. And then we're now adding a positive, so we're going to go up a little bit, 0.09091. This is our sum after the first 5. Whew! Well, you know what? That looks like it's getting closer and closer to 0.09 repeating. Oops, I need to extend that all the way there. Which, as a fraction, is 1/11th, but we'll see how to get to that. So you've got some other strategies. Hey, you know what? I want you to do some thinking. What could you have done other than what I wrote here to be able to get to those sums? Really saying, the way I'm doing it is not the only way. You got to be doing some thinking as well. And now I alluded to this already. In order to know if we have a finite sum when we go to infinity, it all depends on convergent versus divergent. And which is the one that we need to have? Well, we need to have convergent. Divergent? No go on that one. And we know if something's convergent, it all comes down to the R value. The R value is always going to be between 1 and -1 there. In other words, we got to multiply by something that's going to bring the number closer to 0. So if it's bringing it closer to 0, that means it's bringing our r to the n into 0. Well, if that's going to 0, we got 1 minus 0. That's just multiplying by 1. So then we got t1 over 1 minus r, which sounds like an awfully nice formula to be able to use. the sum as it goes to infinity equals T1 over 1 minus R. That's on your formula sheet. And just put down something there. Why does this rule not apply if we've got R less than or equal to -1 or greater than or equal to 1? Okay, so have something there ready to participate with that question. And I know a lot of people, they always want to know why we learn in this stuff. Here's one reason. So anyways, an infinite number of mathematicians walk into a bar. First one orders a beer. Second one orders a half a beer. Third one orders a quarter of beer. The bartender says, you're all idiots, and pours 2 beers. All right, figure out, is it convergent or is it divergent? If it converges, what's the sum? Well, all comes down to what's the R value. So let's find our R value. R is equal to, and R is 8 over 32, which is 1/4. So yes, that converges. So we're good to go on this one. So then S with fallen over 8, the infinity sign, equals T1 over 1 minus R. And we, again, formula base, so then that means T1 is equal to 32, R is equal to 1/4. Those are the only 2 things we need to know for this one. Plug her in. 32 over 1 minus 1/4 equals 32 over 3/4. Hey, dividing, there's our main divide sign. Dividing is the same as multiplying by the reciprocal. So in order to keep this one going here, put that there, we've got 32 multiplied by the reciprocal of 3/4, 4/3. Now we want to divide before multiplying. Go 32 divided by 3. That doesn't divide evenly, so we're just going to keep it as something over 3. Go 32 times 4 now. That's 128. We're going to get 128 over 3, which is approximately equal to, in decimal form, 42.6 repeating. I prefer you keep it into your fraction form here. Don't go to decimal unless I ask for decimal. All right, check out the next one. Is it convergent or divergent? Find your R value. So -10 over 100, and that gives us -1/10. So yep, that is convergent. So we're good to go on this one. Again, formula. And what are we looking for? We need T1, which is 100, and we need our R, which is -1/10, and let's just plug it in. So it equals 100 over 1 minus a -10. And the denominator there is 1 plus 1/10. Oh, that's 11/10. Again, here's your main divide sign. So then we're doing our dividing is the same as multiplying by reciprocal. 100 times the reciprocal of the denominator. 11 over 10, that's 10 over 11. Okay. See if you can divide first. 100 divided by 11. No go on that one. So let's multiply 100 times 10, which gives us 1,000 over 11. There's your sum as a fraction. If we take it to a decimal, approximately equal to 90.90, with the 90 repeating. So what's the point of doing this? Good. Thank you for asking. Question number 3 there. Take 0.16 repeating into a fraction. Really what we're doing here is we're going right back to that first getting started question. Let's make it into a geometric sequence and series. And then now we can take it and use our formula. Let's break it up. We've got 0.16. Those 6's keep going on. So this is just like the first question, except we got a 0.1 to start with. And then we've got a 0.06. Then we've got a 0.006 and a 0.0006. And on and on and on. Well, you know what? This 0.1, that's actually not part of the full sequence. That's out of the rest of them. Everything after that, the repeating part, forms a geometric sequence. So we're going to break it into two different sections. The part that is not repeating and the part that is repeating. We'll just work with the part that is repeating, because that's the geometric part. So in this one, T1 is 0.06. Our ratio is T2 divided by T1, which gives us 1/10, or 0.1. Because the whole point of this is to get to a fraction, I'm not going to use the decimal 0.06. I need that as a fraction. That's 6 over 100. If you want to take it down to lowest terms, great, go ahead. We can do it now, we can do it later, doesn't really matter. I'm just going to keep it as 100 because it's nice and easy to use, and the other one was a 10. Well, into our formula we go. T1 over 1 minus r. Let's fill it in. T1 is 6 over 100. 1 minus 1/10. Okay, well that's 6 over 100 over, there's the main divide sign. Got to make sure you remember where that one is. Over 9/10. Dividing is the same as multiplying by the reciprocal. So we've got 6 over 100 multiplied by 10 over 9. Divide before multiplying. What I mean there is we've got a 10 and a 100. Hey, I can divide both of those by 10. Hi-ya, that's 1. Hi-ya, that's 10. Hey, the 6 and the 9. I can take that to lowest terms fraction. 6 and 9, I can divide each of them by 3. Hi-ya, that gives me a 2. Hi-ya, that gives me a 3. Hey, the 2 and the 10, I could take that down to lower terms. Let's do that. Divide that by 2. Divide that one by 2 as well. And now I've got it down to lowest terms, so I just got to look at my outside numbers. And I've got 1 times 1, so that's 1 over 5 times 3, that's 15. 1/15. But this is not my answer. This is just the repeating part. The repeating part is 1/15. Now I've got to add it to my beginning part. That was 0.1. Or in other words, 1/10. Plus, this part came out to be 1/15. And now we got to add some fraction work. 1/10 plus 1/15. I need a common denominator. Common denominator is going to be 30. So let's multiply the first one by 3, multiply the second one by 2, and we come up with 3 over 30 plus 2 over 30 equals 5 over 30. Take it down to lowest terms now. Divide each of them by 5. Hey, that's 1/6. There's the process. And now you can actually take any repeating decimal into a fraction. And I know that's exactly what you wanted to be able to do. So now you can. All right, bring that knowledge back together. Just recap what you've learned. Answer your 2 discussion questions that we'll go through in class. And then we'll be able to go through and practice up those new skills that you've just learned. See you then.